So, you know, I'll do my best to follow along, but I have not worked on any of it. Kind of just looking to get started.
Mhm.
Yeah, sure. So what the plan is right now is we're gonna try to introduce a tuple type. We're working on the dark code base itself, so it might seem a little bit overwhelming at first because if you haven't used dark, you might not understand why we're doing some of the things. But I'm hoping after a while it start to make sense. So
Awesome. Thanks.
just follow along. Cool. So I have started the recording now. So Paul, take it away. What do you want me to do next?
So we are looking at adding a tuple type. So that's going to be something where in the editor, where if you press a parens, you will get an empty tuple, and then you will get that tuple extended.
Okay. So can you repeat that again?
Sorry, just excuse me 1 second.
Yeah, sure. Nice background. You got it working?
Oh, yeah, thanks. Yeah, I know. It's my fiance's shoes and mine.
I've been reading some OCaml tutorials in the morning.
Awesome.
Just trying to get the hang of it. I haven't used OCaml before, so that'd be interesting. Okay, so you're saying when I press bracket, right?
Yeah.
Okay.
So what we'll want there, well, I guess it'll be very similar to using square brackets. So if you press a square bracket now, and then we add a comma, then we get further things in it. So it'll be extremely similar to that.
Okay. Okay, but it's just going to be a tuple instead of an array when we're doing this.
Yes, exactly.
Okay. Cool. Okay.
So do you want to start at front end or back end?
I don't have a preference.
Okay. So let's start at the front end then, because we can do this without sending it to the server.
Okay.
So for that, I want to start in client and then types. Sorry.
All right.
I think it's in core. And then types.ml. So this is where basically every type in the entire front end is. Not 100% true, but it's maybe 95% true. And if you search for elet, capital E, capital L-E-T.
Capital E, capital L?
Yeah. Or E lambda maybe might be an easy one to do. That is actually in a different file. That is in libshared.
Libshared. It's not in the client, or
it's not in client. It's actually stored outside the client. Libshared and fluid expression.ml.
Okay.
Yeah. So these are all the existing types. And
I see.
So you'll probably recognize most of the things as just being the standard dark type.
Gotcha. Yeah.
And everything has an ID as well. T is just a reference to another expression. So we're going to add another one here. And if we look at elist, which is, so it's basically going to be the same thing as that.
Okay. Something like this, or it's going to be
list.
T-list. Okay. Okay.
And then that should actually be enough to get compiler errors to guide us the most of the way through the front end.
Okay. So the compiler is now gonna start.
So this is the backend running first, but we can do the backend as well.
Okay, should I be opening up something else, another process for the front end, or it's just one process?
No, so it's all done. Builder compiles everything.
Okay.
So the first thing we see here is that there's an MLI and an ML. So MLI is sort of like the header file. It describes the interface, so we need to add it. It's defined in both places, and so we need to make them equivalent.
Okay, so should I just copy this line and put it right after, I think it's right after the list. List. Like this. It's probably a little different, like shared. I'm just trying to find patterns here.
Yep.
I'm hoping it will start to make sense to me eventually. So yeah, that looks legit. It's valid.
There was a comment there that was attached to the list, and we put the tuple above it, so we should put the tuple below it.
We should put the tuple right here. Got it. Okay. Oh, okay. So the comment was for the stuff above.
Yeah.
Like this comment. Okay. Got it.
No, I don't actually know what the comment says. Shared.id in the list is extra for the field name. Huh. No idea what that means. I think that comment might be lost. Might have been connected to something else in the past.
And then now it's just noise.
Yeah.
Okay.
Yeah, maybe delete that comment. I have no idea what it goes with. So.
Okay. No worries. Cool. So let's see what the backend is saying now.
Sorry, can I ask a question?
Yeah. Totally.
I just wonder, because OCaml itself have a tuple, but why we use the list of the type expression here? Or is that how we serialize in general?
So OCaml does have a tuple. The reason we're not using it is because the type, we want it to have any number of possible entries. And the tuple in OCaml has a specific number of entries and specific types.
All right. So we want to allow the kind of unlimited tuple process.
Yeah, exactly. If we used a tuple here, it would be specifically one item or two items or three items.
Okay. Yeah, thanks.
Good question. Okay.
Okay, so that's great. So the compiler is going to tell us all the places that that it is not exhaustive. So that means that there's a pattern match that we haven't handled our tuple. So so that's probably a good place to start. The fluid expression .ml 740.
Okay.
.ml. That's the ML, yeah.
Okay.
So this function to human readable, it just prints out a string for how it should be read by a human. I think this is for debugging or for error messages maybe.
Okay. Is it consumed by the front end?
This is, it is probably both front end and back end. I think it's for testing. I'm not actually sure where this is used. So find elist, add it in. So on 822 there we have elist.
I can just add it in after this. Oh.
Yeah, exactly.
And it'll be like this or something? Like how?
No, it'll be expert. Yeah. Okay. So.
Work. Okay. Okay. So how do we want it to print out?
Same thing as list is probably fine. Oh, so except it would say tuple.
Okay, sure. And what do we want to just do? New line list?
Yeah,
well?
Yeah, exactly.
This is invoking the function new line list, right?
Yeah, that's right.
Okay, and it's passing this.
So yeah, what's happening there is new line list is going to return a string, and the printf there will inject it where the percentage s says, and then it returns a string.
Gotcha. Okay.
And that new line L is a lowercase, it seems. L should be lowercase.
Oh my God, that was very hard to tell. Okay, so let's see what else we get. Were there some other spots that you noticed that I can
Yeah,
jump to
so
right
like,
now?
like 30 of them go by. All
Oh,
these.
wow.
And this is one of the reasons that we don't really use I'm trying to think of the name of it, wildcard patterns that much. So you're allowed in these match statements just have a final one that's like, you know, wildcard. And we never do that because when you add one, there's so many places to add it that it won't work if we do that. So
Okay.
we try to get exhaustive checking everywhere.
Okay, so here I'm getting you forgot to handle a possible case here. For example, e-tuple, blah, blah, blah. On line 650. Should I go there next?
Yeah, just whatever the error message says, let's go there.
By the way, Paul, I've never worked in Tuple. I've never worked in OCaml before, so I was learning her this morning, just the hello world sort of thing. So this is me. I've done functional programming before though, so like I might ask some stupid questions.
So I imagine that this is the equality function. If you go to the top of the function, we'll see what this is called. I imagine it's like
Test equal ignoring IDs.
Yeah. So this is used in tests to see that we get the right answer. When we create new things, we can't guarantee IDs, so we just want to see, like, is it the same shape?
Is it like a value equality here? This is
Yeah.
like a value check? Okay. So how does this? Okay. So I guess it's also an L or T. What do you want to call it?
So we often call them expers.
Yeah, but I don't see that consistent. I see like V. I'm assuming V means like value here.
I see T's in eConstructor. That's probably relatively common. But I think it's safe to say that there's no there's not that much consistency here.
Then just L?
L is fine, yeah.
Yeah, it is. I'll go with a list of values if you want to think of it like that. So we have that, and then we have like the e-tuple L prime is, and do we want to just do EQ list?
Yeah.
I think it works out.
We already have established that they're both tuples.
Yeah.
And so now we're establishing that their contents are the same.
Okay.
I think you can generally just scroll up to the previous thing. You don't have it set up to do the go to next error?
I don't. I had my Reason ML plugin set up before in IntelliJ, but it's giving me an error saying compatible until build blah blah, and I don't know, maybe my IntelliJ updated and they haven't updated the plugin. And I have Visual Studio Code, but I'm not as like fast on the editor with Visual Studio Code, but I can try it.
I wouldn't bother switching. I think just like keeping going is probably
I just have to keep like finding the places. Yeah. So
I think that's the same function.
Okay.
And so what this pattern that we're probably seeing here, you see that we trade off one versus the other, like tuple versus tuple. I think if we get to the bottom, we'll have wildcard matches. So you see we have it matched against everything else. So we want an e-tuple matched against everything else is false.
Gotcha. Okay. This is like the default case. If,
So the underscore here is to say just like we can ignore
anything.
them.
Gotcha.
So we're ignoring the arguments of the e-tuple, and then we're ignoring whatever else is there.
Gotcha. Okay.
All right, 563. Ancestors, okay?
Okay, so this is like you're trying to find the ancestors of that element in the AST? Okay.
And I think just copying list will work exactly the same.
I feel like this is my backlog here, our backlog right now.
Yep, that's exactly.
Let me just copy this. The line numbers will probably change a little bit, but that's okay. All right, so 490, 546. What is this function? Clone.
Ah, nice and simple. GID there is generates a new ID, generate ID.
Okay.
And a pattern that we often do in our functions is that we write a partial function that works on lists of expressions. So that's, in this case, it's CL. So it's like clone list.
Okay. So this should be okay, right? This should work.
Yeah, exactly.
And then 497. Yep, that was a clone function. 340. Deprecated walk.
Do we still use deprecated walk anywhere? Maybe, can you search the code base for deprecated walk? We do. All right. Yeah, we're gonna have to put it in. But it'll just be the same as elist.
Okay. List.map. Post traversal. Oh man, post traversal. There's like a particular way to like traverse a tree, right?
Yeah.
I forgot the pattern. Okay.
Sure, this will be exactly the same as an elist again.
Yeah. Okay. And is that what this list map is this doing the post traversal?
Yeah. So what that says, what the list map there says is that tilde f is saying that the function that we are mapping across the expers is the function r. And then you can see on line 292 there, r is just this function,
Gotcha.
the call to post traversal. So it's called r because it's just recursing.
Okay. Okay. All right. Let's see how we're doing here. We have a few more. 248. Pre-traversal, of course.
Yeah.
And then it's just the pre-traversal function being used here.
Yeah.
Okay. Children. Well, that should be pretty similar to a list, I guess.
Yep.
Here we go. And then find. So given a target and expression. Okay.
So so basically we're just defining the recursion here, and it'll be exactly the same.
Makes sense. Find expression or pattern. Okay.
Well, same.
Okay. This is the 2ID, same Same thing, just like take the ID value and okay. Okay, let's see what we get.
Okay, so we're into the next file, encoders.ml.
Okay.
So encoders.ml is for JSON encoding to send it to the server, typically.
Okay.
Do you have a line number?
Do I get a list of the failing spots? Okay, never mind. It just seems like only 3 places. Oh, sorry, that's AST and encoders. Okay, so this is in lines 671 is the match that is saying it's not exhaustive. Fluid expression. Okay, so this one is
here is that we're saying encode a variant. A variant is a sum type. So encode the variant elist, and its arguments are ID, and then exprs, which are going to be encoded as a list.
Okay.
And so we're going to do exactly the same, except we're going to call it eTuple.
Okay.
Now, one place that we don't have exhaustive matching is going the opposite direction from, so in the decoders. So worth opening the decoders at this point and search for the string elist, like with quotes around it. There we go. So we want a similar thing there.
at the decode. Okay, yeah. This will take the tuple and then the e tuple. I'm guessing.
Yep. So X is the ID, Y is the list, and
Okay.
the next decoders are listed.
Okay, cool. What's the updated? We also have some failures in AST.ml. Should I just go and handle it there too?
That's the wrong AST.ml. You want the all caps one.
Gotcha. Yeah. It's in the source, client source Fluid. Fluid is the editor that you guys built, right? For the front end, like the code editor. That's what you called it, right? Okay. Uses.
Yep, that's good.
So this is going to take expressions and then pipe that into this function here.
Find all of the uses in the expressions. So basically, given a variable, you're trying to find where it's used. So it may be used within the tuple. So let's find everything in each of the tuple expressions and then concatenate them.
Got it. Okay. And then there was another failure in AS. Probably look for elist here. This is the exec symbolic expression execution.
Symbolic execution. I can't remember where this is actually used. I think this is for finding variable names within it or something like that. But yeah, copy it and.
Okay. And then SEXE. Okay. Cool. So what do we get? Fluid tokenizer.ml.
So the fluid, so the way that the fluid editor works is sort of a reverse parser. So we have an expression and we convert it into tokens. and then we display the tokens on the screen. So
Okay.
the token is sort of a pretty printer is a way of thinking about it.
Okay. Well, this is pretty big, which makes sense. There's a lot going on.
So yeah, so what happens here is we have lists can be quite long. Theoretically, tuples could be quite long as well. So we may as well just like literally copy the same code.
Okay.
And then where we see list in here, so we see T list open. So that's about 4 lines down. So what's happening here? B is a buffer. So we're adding these tokens to a buffer. So we're adding T list open, which is the open square brackets. So we're going to want to change that to T tuple open.
There, right?
Yeah, exactly. And then there's probably a separator in here somewhere.
Our separator will still be comma, right?
Yes, but it might be, I'm not sure if the separator is, oh yeah, so it's T list comma. We want to change that to double
There's
comma.
also T list close here.
So we'll change that one as well.
I'm gonna do both comma and close. So those are 3 functions we're gonna have to implement as well, right?
Those are variants in an enum.
Okay.
But yeah, we'll have to implement those, and the compiler will tell us at some point when it is time.
Okay. Cool. What's next? We found a bug for you. That's pretty soon. Okay.
Okay, so we have to find the definition of that. Yeah.
It's like
there.
let.
I think it was in types.ml. Second one down. Yeah, there we go. So yeah, we can just do that exactly the same.
Okay. Probably should just copy all 3 of these. I think I'll need them, right? Because I'll need the T tuple open, close, and comma as well, right? Okay. Let's see. Now we are in fluid token still, 9 of 4.
So now we're going to have to take these things and bring them to all of the exhaustiveness places as well.
Okay. So fluid token that. Matches content.
That's very similar to the to what we did a few minutes ago with the
I think it's like here.
Yep. Perfect.
Okay.
There must be a list open as well.
Is that like the?
That's interesting that there isn't one.
Just like there's these guys here at the end.
Yeah. I think this is only used in one place. Actually, check if it's used at all.
What this function or the list open? Like, check what?
Yeah, check that whether team. Sorry, what the function is called matches content. See if that's it is used in one place. All right, still used in one place.
Mm-hmm.
We use that for keeping the when we reflow a line for trying to keep the cursor in the same place, but that was the first way we did it, and it didn't work all that well. So we went to a better way, but I guess there's still one place that uses it.
Okay. Yeah, to category name.
Yep. So we can do the same thing here, except it's called tuple.
Yeah, we're gonna have a new category.
This is typically used for CSS. So we should look in the CSS files to see if there's anything with the string list.
Okay, 1 second. I just kind of lost where I was. There's the token.
There we go. So have a look for list in, I think it's probably called fluid.scss. See if we do anything special with the list.
There's just one occurrence of list.
Okay, so probably seems fine.
Pardon? Missed that.
That seems fine, then we don't do anything.
Okay. Okay. Cool. There was a lot of other places where I saw the list open, list close, list comma, and this.
Do them all.
So this one matches content, which I guess we did the list tuple comma. We did the list comma equivalents, but we didn't tackle the list open or close. Should I also just go ahead and add those as well? Why aren't these like closer together?
Because comma refers to another, comma has two IDs. Oh, sorry, comma has an index, whereas open and close don't have indexes.
Okay.
I was just thinking the same thing.
See list open. I think we copied that. Yeah. Okay, this one we did not. And what method is this? TID. This for getting the ID. Same thing.
Open is what connects it back to the expression it came from. So we did this one a lot.
Parent block ID.
Same, I think.
List literals, object literals. Okay. List open, close. This is text token.
Great.
Okay.
We could do a little tidy up there to replace the T-list comma where it has friends with two things. We can just replace with just one.
Okay. Yeah, makes sense. All right. Let's get an update. State of things. All right. So fluid token line 652. Type name. I thought did I not do this one already?
No, we did category.
Ah, okay, right.
I see list on line 732.
Sorry about that. I can sneeze. Okay.
Yes, comma, yeah.
And do we want to give a new name here, right?
Yeah.
Okay. Let's take take a look at this. Still fluid token, 445. To text. Is that for the front end to give a text representation of the token?
It's usually for tests and
Okay.
for occasionally error messages and such.
Okay. So I'm probably gonna see. Here we go. Oh, look at that. We don't want this to be Is this comment for the line above or below?
To be transparent, so have these make their presence. No idea.
No idea. Okay. Yeah, I'll just leave it for now. So like that.
Yeah.
Okay. So is white space 315. They're not white space, so they're just like default case. Warning number 8. Okay, how many other waters there? Parent block. I thought I already handled parent block ID. Oh, did I miss some? No. I think I may have missed something. Open, close.
Maybe we didn't do
Comma?
I think I saw a comma near the top.
Did you see it? All right. 178. Maybe there isn't a comma being handled for the lists.
Must be in here somewhere. But if you search for T lists.
Okay. Oh, it's right there. Oh, geez. Parent block ID. What's the problem here? Tuple in result.
968, I think, or did I look at the wrong here?
Oh, okay, yeah, different place.
So now I see it in there.
Yeah. Oh, fluid printer. That's a different file. Okay, we're somewhere else now.
Fluid printer is the file that takes the tokenization and turns it into HTML.
Oh, okay. Fun. HTML land. Need to test the case.
So this is just having it print out for test cases.
Mm-hmm. So where are we?
So this is
tuple, right? We look for list.
Yeah.
And what is this? Spaced.
This, I believe this prints out test cases.
Okay. So is that okay for me to copy whatever was going on with list there? Okay.
Did you change the word to tuple or didn't?
Did I miss anything else?
No, on 142. Space.
Oh, okay. Yeah, sure. I work on Ruby every day, like for my work. So I use Ruby mine. That's why I use IntelliJ because it's a very similar experience, but my key bindings are a little bit different. So I'm pressing a button to like highlight a word, but it's taking me up. Fluid ML.
So FluentML is mostly where we define the actual keystrokes.
Oh, okay.
That's why it's 5,000 lines long.
Oh, fun.
So what function are we in?
We are, yeah, that's a good question. Let's take a look. Reconstruct expression from range.
Okay, so reconstruct expression range. This is used for copy paste.
Okay. Because the range is basically the stuff when you select and you copy it and paste it around.
Basically, we rebuild the contents of it based on what you've selected, like leaving out various things. It doesn't work perfectly. I think it's one of those things we need to rethink, but I think here we can just copy
It's
it.
not the biggest issue at the moment yet. And it will call reconstruct.
eTuple is what we want to change this to.
Oh, sorry. Let's do
And then also 5195.
Cool. Okay. 1986. Find appropriate parent to wrap.
Nice.
You have an E-list here? Or... I'm in the right place, right?
E-list is on line 2008.
Okay, yeah.
I think we can skip the tuple as well.
Cool. One 167. Caret target for start of expression.
Oh, this is fun. So this is where this is all part of the reflow stuff.
What's the reflow stuff?
So when you type something and the line becomes too long, we reflow it.
Oh, like you're kind of moving things around to make it still like visible in the small amount of space there.
We need to keep the cursor in the same logical place, not the same physical place. So all this like AST reps is like figure out exactly where we were and then go find the new place that was.
Mm-hmm.
So that's what's happening here. So we're going to need an AR tuple as well.
Yeah.
And LP open, that sounds like left parens open, right parens open. I'm not sure what that means. But let's list parens open, record parens open. This is going to be tuple parens open, TP open.
All right. AR tuple does not exist.
Okay. Types.ml. And see if you found LP open in here as well.
Okay, and this is would I still call it an AST list part? Like would I still use the same implementation? Yeah, okay.
Oh, AST list part, no, it turns out to AST tuple part.
So that's something we'll might need to come back to that. And then we're currently doing so AR tuple. So is that?
I think if you just search for it now, it'll be in the same file, and I think it'll be straightforward to. Yeah, there we go.
Oh, cool. So just be
tuple
part, and this we're saying would be like TP open close comma of int.
Yeah, int is good there as well. It's the index.
Okay. Cool. So that's good. I don't have to do anything with that. Where were we now? We were, so T tuple comma. So we did the AR tuple, and then, okay, so that's now implemented. Oh boy, quite a lot more things coming in. Fluid ML. I didn't handle the AR tuple case in Fluid ML. That was in line 682-ish. So AR list.
Right. So what I'm saying is that if we're looking for an AR and we have found a T-list open, and the IDs are the same, then we are in the right place. So we're
okay. And this has to be also TP open and TP close.
Yep.
Those types, right? Okay.
It's probably an AR. There must be a.
Yeah, there's another one down here.
Great.
Which I guess we would just do tuple. We have our T tuple comma already, right?
Yeah.
Did we add the TP comma, TP open, TP close? I don't think we did that. We haven't done that yet, right?
No, we just did. That was the AS tuple ref.
Okay, right. Okay, right. ASD tuple part. Gotcha. Yeah. Right. So there's probably some more stuff. Fluid ML 3827. Okay, this is the method do infix insert.
Mm-hmm.
Okay.
All
right.
I mean, not anything special to be done here, so I think it's just fine to.
Okay. And I think that's probably it, right?
There might be an exhaustiveness at the bottom. Doesn't seem like it.
No. Three, 5, 4, 6. AR tuple. This is an exhaustiveness for which method? Okay, I'm not gonna scroll up any further.
How long is this?
It's 29 places of AR list. So I feel like that's probably gonna require
That's
similar amount.
Let's leave that for a moment.
Yeah. I'll follow the compiler's errors.
Yeah, we'll have to specifically handle inserting them.
Okay.
But I think everything else will probably be
3311.
expensive.
This is the do expression insert, it seems like.
Okay. And just show me what thing is being called there. Maybe into left partial. So if we are yeah, I think that's fine. I think there's nothing.
Okay.
I think what's happening is just that it's identifying the place that you can just like start typing and something will happen.
Fix me.
This is backspacing.
Okay.
I want to search in this function for AR list.
Just search for all the AR list exhaustive checks. See if I have like.
The problem is the exhaustiveness check. We want to check in the function whether there's a primary thing there, because the exhaustiveness check stops the compiler from telling us that we missed.
Gotcha. So you want me to like search here for?
Yeah, for AR list in this function. So there's not going to be anything in do pattern backspace. So I think, because this is just checking patterns.
Yeah, I don't see.
Yeah. So yeah, for patterns, we're not expecting to see.
Okay. Okay, I've added the AR tuple here. However, some guard clause may match this value. Forgot to handle a possible case. Did I? Was there some more?
I thought I just saw this go by, but I wasn't sure.
Maybe it's these ones that it's referring to that I haven't handled.
Can you check if there's an AR list in this?
Yeah, there is. I added one at the top right here, right next to AR list. So I think it might be talking about the exhaustive case.
Oh, that's the make into partial. And this is in the left partial function. Yeah, so that's probably fine.
Yeah, so I think this is maybe what it's referring to.
Immutable keywords and symbols, that makes sense. So we're into a place where like you're editing the word. So for things that can't be edited, that makes sense that we're excluding them.
Two 720. And this is function do explicit backspace. And
there's AR lists. So yeah, so what's happening here is what happens if we delete the backspace from a list. So we're seeing that the place that the backspace was pressed was on the comma that has an ID, and then the expression that it's dealing with is the list. So I imagine what it does is it goes through and it finds there we go, finds a list and it removes the element. I think we
removes the element.
Yeah, I think we can just literally copy this.
Yeah, it's gonna be the same behavior here as well. It means something else, like it's a tuple, but in terms of how we modify it, it'll be very, very similar.
Yeah.
Okay, so we have. And I can still just do list.update at list.remove at, right?
Yeah.
Like online
this LT comma should be TP on 2789.
Oh, interesting. There's another occurrencing of T. This is interesting. Remove list wrapping from singleton. Do we also want to have this?
Yeah.
No.
Yeah, so if you backspace on the opening brace of an empty thing, we want it to delete.
Gotcha. Okay, that makes sense. Okay. And then there's also AR listing mentioned here. Doesn't have a comment.
So when we're deleting, oh, actually that last one wasn't open. That was just a singleton. So we were turning oh, I see what that was. So the previous one was there's a singleton, it's wrapped in parens. We're just like converting it to not wrapped. Now now we're doing the actual empty list.
Yeah.
So let's add it there. And then
same thing, right? I could just do it in the same line as well. Seems like it'll be okay.
If the line gets too long, there's like the formatter will fix it. So
okay,
the other
cool.
thing we want to do here is see that when e dot empty or e dot is empty. So we want to make sure tuples are handled in is empty. E is probably fluid expression.ml. There we go. So we want to add.
You want me to do like the similar sort of thing? Like, is that okay? L is probably still okay, I think.
Yep.
All right, cool. Let's see where we at.
Ah,
that's getting further.
That's compiling. Oh.
Fluid ML. Did I mess up fluid ML?
Yeah,
I think I'm missing a closing bracket probably.
Oh, no, we have an extra one. So halfway through the line on the right-hand side of X.
Ah, yeah, this one, right?
Okay. The whole thing one.
You forgot to handle a possible case here. Fluid ML 2720. Oh, I did. AR list, AR tuple, AR list, AR tuple. Was there more?
Are you able to search forward for AR list?
Yeah, I can try. So let's go with. All right.
That's fine. Tuple, yeah. Ah.
Okay, I think I missed these guys.
Let's say keep going.
Just search probably as well. Many more. Okay, looks like I think this is good now. Fluid ML 2623. ID of AST ref. What is AST ref?
The AST ref is the stuff that we were just adding. That's used for the reflow.
Okay.
It's a description of where the cursor is right now. So it's not exactly the same as a token.
Okay. Interesting. Okay, cool.
It's a subset of tokens basically.
Fluid ML 1061.
Ah, yeah, so we did it for the start of the expression, now we're doing it for the end of the expression.
Okay. So we have E list somewhere here, right? End of the closing this thing. There'll probably be a few more places for this. Fluid ML 908. So
There's LPs there.
it's a bunch of LPs. And that should be it.
Yeah.
I was going through quite a lot of changes.
Yeah.
Shotgun surgery.
These are all editor changes. But the editor makes up the 2/3 or more of the code base.
Mm-hmm. Makes sense. AR tuple. What am I missing here? I did not handle it.
Maybe it's it's probably an exhaustive list thing. Search for AR list and this and see what else we find.
Sure. That's looking a little different.
Oh, it's compiled. Holy shit.
Yeah. Is it in progress right now, or is it done?
No,
Okay. Okay.
Yeah, it compiled. So now it's running the tests.
Okay. Sweet.
Test all clear. All right. So
Okay. Paul, give me 1 second. I just have to mute myself. One moment.
Yeah.
Okay. Go ahead. What were you saying?
So what do we got next? So we could add. I think the best thing to do is probably add the code to create tuples so that we can test them.
Okay. Create tuple. Where?
So that well, actually,
should I commit this?
Yeah.
Feels like a commit point. Let me create a new tab. I'm going to call this add tuples. I don't know. I'll call it something else afterwards. I think this is going to get pushed to my fork of dark. Get up. Okay. All right. So
now we'll want to go to code.ml and want to search for either a string or a character that is the open square bracket. Like with quotes around it, I mean.
13 occurrences.
Insert blank or placeholder helper. So what's this do? Yeah, so let's do that. Let's add the same thing here. If we press a parens, then let's make a tuple.
Okay. So if you do else, okay, hold on. We do a parens, then we do an e list.
So what is we're returning both the expression and then a caret target is saying where is the cursor going to be put when it is done. So what we're saying here is that we're going to put the tuple next to the open parens at an offset of 1. So we're going to put it to the right of the open parens.
Okay, gotcha. And that's good, right? This is sufficient, I think.
I think so, yeah. So let's see if that's good enough.
Okay. Do you want me to open up dark in the browser? What was the
dark localhost? darklang.localhost colon 8000.
Okay, there we go. I had it run before, so. And the username and password, do you remember this one? I think it was in the.
WHAT.
Sorry, repeat that again.
The password is WHAT.
My one password shows up. Okay, cool. So there's my hello world.
Okay, so if you delete all that, I can open parens. Let's see what we get.
Oh, here we go. Moment of truth.
Yeah. No, this is great. So what's happening?
It's progress. It is not red, so
Right.
it's good.
I send it to the server, and the server doesn't understand it, but that's great.
Cool. Sorry, repeat.
Add a comma, see what happens.
Can't.
What about backspace? Great. Okay, so now let's figure out how to add commas.
Okay.
So search for quote, comma, quote.
8 occurrences.
Okay. So this is great. So we see it there.
So now you need to know whether you're inside of a tuple or inside of a list, right?
Right. So what we see there is if we're in a T-list open and we're on the edge, so on the edges between two tokens. So we have an insert in list. So this is exactly where we want to add it for tuples. And then we see the next two are also. So this is if you are to the left of a comma and you're adding another comma. If you're to the right of a comma and you're adding another comma. And then if you're at the close of a list. Yeah, so we want
Okay. All these behaviors we want to just copy, right?
Not the top one.
Oh, sorry. Okay. Is this comma comment?
I think we're going to be adding it to under that.
We'll just kind of part of that, right? Like commas.
Yeah, because the list stuff is happening, and then we get to the lambda stuff. So we want to be between the list and the lambda.
Okay, so there's this insert in list method, which I don't think we have yet. We have to implement as well,
I think we're
right?
going to have to do insert in tuple.
Tuple, yeah. Yeah, that's what I meant. Okay, so I think. Okay, so yeah, insert at tuple. Okay, so let's do that. So we have insert in tuple and insert at tuple end.
You say tuple as well. Americans say tuple.
I say both. Honestly, I don't know, like, because we use that pairing program. It's like a little bit more optimized for pairing. Sometimes tuple, sometimes tuple. Tuple me, tuple me. Okay. So
yeah,
that's cool. So would that now just let the comma work?
I think so. Yeah, I think that's all the comma. So hang on, just go back. So we've got it for open and close. And yeah.
So we still need to implement the.
We still need to implement insert and tuple. So if we find insert in list, there's also insert at list end. I see. So we're going to need to do insert.
Insert. I think. Yeah. Insert tuple end. Yeah. Okay. So let me find insert in list. In fluid ML.
Great. It's going to be easy.
Okay. Was it like 2 spaces? Yeah, it looks like 2 spaces. 2 spaces. Okay.
The formatter will fix that anyway.
I don't want that one. Okay, I'll undo that one. We still want list.insert at, right?
Yep.
Okay.
And where it says not a list in insert tuple, not a tuple. Same in the next one.
Cool.
So the fluid AST, it looks for the ID, and we know the ID from the token. So it looks for the ID and does a replace inline, and so it knows that it shouldn't get a tuple, and that it should get a tuple, and if it doesn't, then logic error, it'll keep going, but it will file a log and will send something to the error tracker.
Okay, cool. All right. So now I've inserted tuple and inserted tuple end, which will allow.
Yeah, I think in all likelihood.
Okay. So let's. I don't have to refresh this, right? Is it just gonna work, or should I have to just refresh?
Refresh automatically. There's two different ways of doing that, and they're both broken.
Okay. Well, I'll just refresh. Okay, cool.
All right.
So I've got my regular list works. Okay, and then comma.
And then try typing it. Try like putting numbers and stuff in the blanks.
Oh, 5.
And what happens if we delete things?
So like foo equals ASDF.
Rename foo. Nice.
Slick.
Then, yeah.
That is pretty cool. Yeah, I just did backspacing. So do you want me to delete the whole thing? Yeah.
Okay. So yeah, this it looks a lot like this all works.
Yeah. So now it's just a matter of I guess the backend needs to
So
have some work as well.
I would commit this.
That's a commit point, yeah.
Test for it, and then we can do the backend. And the tests we're also just going to copy.
Okay, so this is what we allow adding commas and yeah, basic commas and elements. Okay, cool. So what's next?
Next up is tests. So go to fluidtest.ml. And search for lists.
Describe lists.
Yeah, so I would copy everything.
Up to here, right? Okay. A lot of the cases will not apply to a tuple, right?
Maybe.
I guess we'll find out.
Yeah.
Tuples. Create.
Yeah.
Oh boy, not gonna.
Yeah. So let me explain what the thing is saying here. Okay, so T create list. So that there's a test. It's called create tuple.
Mm-hmm.
We start with a blank. We start in position 0, and then we insert a character. And then the stringified version of the result should be this empty list with the caret in the tilde's position. So that this is where the caret should be.
What's this purpose of this thing?
That is where the cursor is.
Oh, the cursor. Okay, so that's kind of like a special character in the tests right now to see where you end up. Okay. So, yeah, it's a lot of test cases.
I think if we change the words list in every case, and we change the square brackets to curly or to friends.
All right, let's see what happens. There's also like this list function.
Yeah, we're gonna have to add some.
Okay. Nested tuple. Ooh.
Oops.
I feel like it's gonna be a lot of stuff. Yeah. Very long tuple.
Give me 1 moment.
Sure. I'm gonna try to do some regex replace here because I need a square bracket that's inside of a double quote within this selection. So
Yeah.
let me try. Let me try to be a little bit more effective with this. In selection, I want regular expression within a.
You need a regex? You just need I think you don't want a regex.
Okay, so the thing is, if I try to replace square brackets without looking for them inside of double quotes, I might end up matching on these guys.
I agree that you want that.
Okay, do you have a better approach for me to not have to
Search for just quote open?
Oh, actually, yeah, you know what? That's right. I can just do that. Okay. Yeah, because they'll always be in the together, right?
Well,
let's see. That's a better idea. Cool. So I want to replace that one.
50.
There's some that are going to have to be manually modified, but
I say replace all.
all right. You said it. I'm just driving. Okay. Same thing here. And then this guy. So that's the most of the stuff.
So let's
We
compile first.
we probably need, like, some of these methods are not going to be there.
Those are in fluid shortcuts. Yes, if you search for list in there. There we go. So we'll want the same one for tuple.
Spacing seems a little like odd. Sometimes there's two spaces, sometimes there isn't.
Yeah, I think that the formatter does that. If it's all in one line, I think it just puts one space, and if it's
Okay. So in that case, I think it's okay. Okay.
Line 31 needs to be an E tuple.
Okay. And then T list is okay here.
Yeah.
Okay. Yeah, empty tuple is not a thing. Empty list, where's that defined? Fluid printer test?
No, I think I thought it was in shortcuts actually. Oh, fluid test. There we go.
Yeah. Okay. So we probably want something like this, right? Like lists, but like this, right?
Yep. I think we might need to rename some of the list ones as well to like single and multi and that sort of thing.
Yeah. I guess instead of very long, I would call it like very big tuple.
Right.
But I guess I could just rename it. Oh.
Not used?
That's weird because I did see it being used here. There was like that one place with a very, maybe I missed that. Maybe I didn't update the word list, capital L-I-S-T. I did lowercase L-I-S-T, yeah. That's why. There you go. So now, You'll see this is getting.
What I was suggesting is that there's a bunch of these names that are going to conflict because they don't have list in them, like single and multi and with stir.
Yeah, you're right. Okay. We can just add those in, right?
Yeah.
Single tuple, tuple, single multi-tuple, with tuple with string, and then big tuple. Okay.
Then all these lists are going to have to become tuples.
Here, right? I think that's the last method. Oh, I also have these guys. Okay.
Great.
Cool. Okay, I'll let the tests are running right now. And
is it compiling?
So it is compiling it.
Because the names are shadowed, or
yeah, I think we'll have to probably go through these.
Yeah.
And I guess what we should have probably done is like refactor the original names.
Yeah.
To make space.
Can we do that?
But I
all our thing as well.
Yeah, I'll just continue on this path right now. I'm okay. So empty tuple, single. I guess it'll be like single tuple. Let I reference the test data. Yeah, single tuple.
Single tuple.
Let's stir of multi. Empty tuple, single tuple, single tuple. This one doesn't have anything.
With stir on 4126 is tuple with stir.
Every tuple. Let's see if there's any more. So it was tuple with stir, empty tuple, multi tuple, big tuple, tuple with blank. I think we have that. Yeah, we do have that. Multi tuple with stirs. We have that as well. I'm saving constantly as well to let the compiler get a head start. Very big tuple. A tuple of long flows does not break upon wrap. That one doesn't look like it's using any test data. Very big tuple, shortened, ML stirred with space.
So see the inserting there, those should be, the description should say
inserting round parentheses, right? Excuse me. Okay.
I see a bunch there.
Inserting square bracket, inserting. Okay.
Oh, backspacing, there's one there, backspacing, square, deleting. Square. I don't know if I'd bother to search for them, but.
Then deleting, seems like probably just one.
Yeah. All right, how's our test doing?
Let's take a look. Ooh. And that didn't look very good.
What did you do? Wow.
That's a lie. Like we've made more progress than that. Okay.
Oh, this is great. This is what tests are for.
Yeah. Okay. So when I delete with caret before tuple with just a blank, removes the blank in LFF.
Feature flag. But so the tests are all duplicated, so actually only 21 are failing. But the ones that fail also fail when they're happening in feature flag.
Okay. Cool. So which ones to tackle next?
Let's try the last one. Insert into empty tuple inserts. Okay, so if we've got an empty tuple, and in position 1 we enter 5. You know, I thought we had tested that. Do you want to take a look and see if that works in the browser?
Yeah, insert into empty tuple inserts. Yeah.
That makes sense. I think we might not have added that case.
Okay, so I have an empty tuple.
And then press, yeah, okay. So we must not have added that case. So there's probably a T list open somewhere. Oh, actually check it works with lists. I'm sure it must. So if you enter 5. Yeah, so that does work.
Mm-hmm. So what's going on?
So I think we just forgot to add it. So if we go to fluid.ml and search for T-list open. So insert a singleton list. So that's one place that we didn't handle. So that one isn't the same thing. Well, actually, yeah, you should add T-tuple in there.
We should, right? Okay. So when you add
No, so this is a different thing. What this is doing is this is wrapping an existing thing in a list.
Okay.
So we do want to add T-tuple open, allow people wrap tuples in lists.
Yeah.
But
that's not the thing that's causing the failure right now.
Right.
Should I just go ahead and?
Yeah, I would go ahead and do it.
We're going to have to come back to it otherwise anyway. Okay.
So a few of these tests are definitely inserting a singleton list. If you copy all this, and we'll do insert a singleton tuple as well.
Okay, so copy this in other places that you think
from 4471 to 4492.
Oh, I see. Inserts a singleton list. So copy this and insert a singleton tuple. And then this would be like, all of these are going to be our round bracket, right?
Yep. And then
you can do a tuple within a tuple.
Yeah, sure, why not?
Okay.
And then where we
this
see
is not an E list anymore, right? This would be
tuple. And then move caret to a TP open. All right, so I'd say this will fix a small handful of tests.
Okay.
And I see line 4522 is the next thing that we want to fix.
Yeah, there's like 7 occurrences of T list open. So
let's see how our tests are doing.
Yeah.
20.
It's less, right?
Yeah.
Okay, so typing between record. Okay, so where were we? You said 457?
452. Yeah.
Typing between empty lists symbols.
Yeah. Perfect. That was the thing that we tried to do and couldn't.
Move to carry target, blah, blah.
Yep, seems good. Have a look at insert in blank expression. See what that is? Okay. Can you go to the definition? Another 3 down. The one with the let at the start of the line.
All right.
Okay, that seems. How about maybe insert in blank expression? Huh.
Is it probably in this file, right?
And then insert blank or placeholder helper. I think that was one of the first place that we added.
Insert in placeholder expression.
Scroll down a little more, a little further. Oh. No, the one line 1537. Where is that defined?
ML.
Okay, we added it already.
Yeah, we already added it.
Okay.
Yeah, that was one of the first things that we added. I remember now.
How's our test doing? 18. I thought that'd be better. Okay, do you want to see
the UI? See if we made some more progress.
Well, so that one passed, but we want to see insert space into multi-tuple. We want to see what that test is.
Sure. This one.
Okay, so in the 6th position, 0, 1, 2, 3, 4, 5, 6. So we start after the 8. So it's multi.
Yeah.
That's list. It should be multi-tuple.
Where do you see that multi?
Hey, stop. To the right. It says multi.
Oh, gotcha. Oh, yeah. This is the, okay, multi-tuple, and then single tuple, and then single tuple. Okay. Because I renamed them all here, right? Because they were in multiple lines. I didn't catch these guys.
It might make sense to go and fix the list shortcuts so that we don't hit that again.
Okay, so that would be,
test
yeah, it's probably better to just do it now. That might be hard to find though. Because I've already renamed these guys to single tuple.
Right. Well, you don't need to find them. The compiler will tell you where they are because it won't know the name anymore.
Okay, single tuple, multi-tuple. Oh, sorry, list. What am I doing? Okay, so just those 3.
I think there's more at the bottom, more below.
Yeah, I think you're right.
After this very long list.
Multi-list. I think that's it.
Yep. Yeah, great.
So just those 4. So single list.
So if you the compiler will tell you now.
Yeah, I'll just grab the obvious ones that I know.
3 at 14 is one as well. Oh yeah.
And the with stir.
Is it
multi?
This editor is the most tested thing I've ever worked on.
Lots of fun cases though. Lots of fun edge cases. Multi with stirs, line 3931. multi 4031.
Another one.
I have a bunch of these as well.
Well, that explains why a lot of our tests were failing.
Yeah, that refactoring earlier would have been good for us. I don't know which test am I tab at the end of my wraps to beginning. I guess this will be multi. Anything that's like not a diff that I'm working on is basically going to be multi-list, right?
Yeah. Can you fix the typo on 5422 while we're here?
Okay. Doesn't give me a
Beginning? Yeah, that looks right.
That's not the only one though.
Oh, tests are running. That means it compiles.
Yeah, it's compiling.
14. Okay. Close bracket at the end of tuple is swallowed. That should be straightforward. So let's look for T list close.
I messed that up. My assertion is just wrong. Okay.
That's handy. And we do actually print out what's wrong with it, so we should actually look at this. Okay, so just scroll up a bit. Yeah. In the test. So inserting, there's a couple of these that where the expected is a test, or it has square brackets.
Yeah, yeah. These just look wrong, right?
Yeah. Yeah, so that it's the expected that's wrong there. So inserting open parens, or what's the name of those?
Where's that coming? Those guys coming from?
There we go.
You see something?
Oh yeah, here.
Is that in another tuple? Oh, okay.
Yeah.
So
it starts with an empty tuple and wraps it in another. So we could actually have started with multi-list and
I think that's gonna do those two cases. I just fired up the compiler again, so it'll run the tests. Just doing a little scan. My eyes.
Oh, here's one maybe. A nest let A, very big tuple, yes.
Oh boy, the zoom window's not in my way. Okay. Yeah, because I got this line. This one I got.
Yeah.
Okay. Okay, I think that's looking better. What about this? Would we do like a tuple match?
Insert separator after. So yeah, I guess we should be able to match on it. I think we don't actually support matching for
So that'll probably
tuples now, but I think it'll work fine.
Okay. All right, let's see what we're at. Oh, that list looks a lot smaller.
Yeah, that looked like just 7 or something.
Mm-hmm. If we can get this done in the 2-hour time span for a modeling session, that'd be pretty epic.
Test cases. So close, and then a delete with the caret before blank in front.
Okay, so let me try this one.
Can you scroll up to the test output? So here, what we've got.
I feel like I'm a superfluous. Okay, here.
Okay, so what's wrong with that first one? Close bracket at the end of tuple is swallowed. What's happening there is that it's not swallowed, and you see there's an extra friends there.
I see. Okay, yeah.
And then same in feature flag, and then a delete with a caret before blank in front of tuple will delete the blank. Looks like we didn't support that use case. A delete with a caret before blank. Yeah, I suspect that we support these for lists and we don't. And the last 4 are all the same.
Okay. Yeah.
Okay, so for the first one, let's look for T-list close.
Just like everywhere, or like find where it's defined.
Okay.
6 occurrences of it.
That looks good. Special case for deleting blanks in front of a list. Great. That was the last 4. That wasn't what I was looking for, but we found
the last 4 thing, right? So should I just copy that and just make a comment for tuples as well? And that's it?
right.
Then we have the TP stuff. T blank.
Yeah, that's a blank token.
Okay. I think that's all the TP.
I think those last 4 should pass now.
Okay, firing off the tests.
And if you want to search for T list close again, or actually search for quoted close parens.
Quoted close parens.
Yeah, there we go. Pressing to go over the last one, so we want the same thing.
So I think we did this for the opening parens, but we didn't do the closing parens, right?
And you got to change that T list close to a T parens close. Oh, sorry, yeah, T top. And then move one right. Just check that that actually moves one right. I presume that's what it does.
Like find where it's defined?
Yeah. Okay, yeah, literally increase the position. Okay. How's our test doing? Moments of truth. Oh, down to 2.
Just 2.
But I think we just fixed that. Those last 2.
Yeah. I don't think we. Well, actually, maybe the update will now tell us the latest results.
Amazing.
That's a commit point, right?
Absolutely.
So what do we achieve here? This one is allow or add. It's basically tests, right? A test coverage.
Test cover and flesh out tuple support in editor.
Cool. Let's take a look at it now and see what's going on here. Okay. Yeah,
Great.
that's pretty neat. Still get bad status internal server error, but
What's happening on the back end is that we haven't added support for the back end, so it's not compiling.
Mhm.
So it's just running with the old thing.
Right.
So we'll need to support evaling and printing and that sort of thing on the back end.
Gotcha.
Next.
Okay. Well, we are at time. It's 2 p.m. right now.
Yeah.
So, like, how much more is the back end work, would you say?
Probably about the same.
Probably the same. Okay. Do we?
But it's yeah, about the same.
Okay. Cool.
And do it then.
Pardon?
Want to schedule another one of these and do it?
Yeah,
then?
yeah. We can definitely schedule another one of these. So, does this time slot work for everybody? Brian and Hector?
I'd say next time.
That's good for me. It's perfect.
Okay. I will upload the video that we've been recording. I'm going to stop the video now.
Yeah.
Stop recording.